Hello friends, in this video I'd like to present my solution to the following problem from the Polish Mathematical Olympiad first round, year 2023. It was problem number 3. So let x and y be real numbers such that x times 4 to the power of x minus 2 to the power of y over 4 to the power of x plus 2 to the power of y equals y times 4 to the power of y minus 2 to the power of x over 4 to the power of y plus 2 to the power of x. Prove that these two numbers are the same up to the absolute value. So absolute value of x equals absolute value of y. So my hints for this problem, it may be beneficial to suppose that our conclusion is false, that x is neither y, neither minus 1, nor minus y. And along the way, it may be helpful to introduce new variables. A equals x plus y, b equals x minus y. So give this problem a try and see you in a minute. Okay, so as I suggested, now let's suppose that x is not equal to y and that x is not equal to minus y. Okay. So let's take our assumption and get rid of the denominators. So we have x times 4 to the power of x minus 2 to the power of y, 4 to the power of y plus 2 to the power of x equals y, 4 to the y minus 2 to the x, 4 to the x plus 2 to the y. And now let's multiply everything. After expansion, we will get the following: x 2 to the power 2x plus 2y plus x 2 to the power 3x minus x times 2 to the power 3y minus x to the power 2x plus y equals y 2 to the power 2x plus 2y plus y 2 to the power 3 times y minus y 2 to the power 3x minus y 2 to the power x plus y. Okay, and now let's group our let's now introduce new variables. Or no, first of all, we can write it like that: x minus y 2 to the power 2x plus 2y plus x plus y 2 to the power 3x minus x plus y 2 to the power 3 times y plus minus x minus y 2 to the power x plus y. Okay, and now we can see that we have x minus y, x plus y, so that suggests to make a substitution. So let a equal x plus y, b equal x minus y. By our assumption, we know that neither of these numbers is 0. And moreover, we can deduce that x equals a plus b over 2 and y equals a minus b over 2. Okay, after substitution, we will get the following: b 2 to the power 2a plus a 2 to the power 3 over 2. Instead of x, we have a plus b. Okay, minus a 2 to the power 3 over 2 Instead of y, we have a minus b minus b minus b 2 to the power a equals 0. I have equals 0 is missing. Okay. And now, what can we do? What can we do? We can now divide both sides by 2 to the power 3a over 2, and we will get b 2 to the power a over 2. So let's combine. This term is b times 2 to the power a over 2, and this term is b 2 to the power minus a over 2 after our division. Here we have plus a 2 to the power 3 2b minus a to the power 2 minus 3 over 2 times b. And that equals 0. And now we can group our expression. So b can be factored out. And here a can be factored out as well. Okay, and now we can put one term on the right hand side, and after division, which is legal because we know that a and b is not equal to 0, we will get the following: 2 to the power a over 2 minus 2 to the power minus a over 2 over a equals minus 2 to the power b over 2 minus 2 to the power minus b over 2 over b. Okay. And now this is impossible. Why? Because the right hand side is positive while the left hand side with this minus is negative. Why is it the case? Because first let's consider two separate cases. If a is greater than 0, then our denominator and numerator, both numerator is greater than 0 and denominator is also greater than 0. So the fraction is positive. But when a is negative, our numerator is negative, and likewise our denominator is also negative. So again, our fraction is positive. The same story for the right hand side. Right hand side, including this minus, is negative always. So it's a contradiction. Positive number cannot be equal to a negative number. Contradiction. Contradiction. So what's the conclusion? That means that either a equals 0 or b equals 0, i.e. x equals 0, x equals y, or x equals minus y. In other words, absolute value of x equals the absolute value of y, which was desired. And that closes our proof and our problem. So thank you for watching. Hope that you learned something new, and see you soon. Goodbye.